Biomimicry comes from two Greek words, bio, meaning life, and mimesis, meaning imitate. But what exactly is the science of biomimicry? Suppose nature has a problem. Bats need to find food. Termites need a cool place to live. Kingfisher birds need to not make a big splash when they hunt for fish. Put the problems in nature's toolkit, and over time, nature finds a solution. Bats use sound waves to find food. Termites build their mounds so hot air escapes and cool air is pulled in. And kingfishers develop a beak shaped like a narrow cone, so when it hits the water, it doesn't cause a splash and the fish don't see it coming. Now suppose you have a human problem. In a war, you need to find enemy airplanes approaching. You want to create a building with a comfortable temperature year-round. Or you're designing a super fast train and you don't want it to create a sonic boom when it travels through a tunnel. Where do you find a solution? That's where scientists, engineers, designers, and architects turn to nature's toolbox, using solutions and strategies used by nature to solve human problems. From bats, we get radar. From termites, we get new building designs. And from kingfishers, we get sleek designs for Japan's bullet train that doesn't create a sonic boom. That's biomimicry. Now that you know what biomimicry is, let's see how scientists learn about it in the lab. Vibhav Durgesh is an associate professor of mechanical engineering at the University of Idaho.
So biomimicry is a field where we look at the nature and learn from it and design engineering application based on that.
One of the best examples of biomimicry used in everyday life is Velcro.
So the person who invented that Velcro in 1950, he was a Swedish engineer, and he saw that the burrs in the nature get stuck to his dog fur. And he looked at it and he came up with the idea of a Velcro.
Humans have been using biomimicry for centuries. Ancient Greeks followed the sun across the sky to tell time and developed the sundial. Leonardo da Vinci tried to invent flying machines by copying the birds. But it was biologist Janine Benyus who coined the term biomimicry in 1997. Durgesh and his students use biomimicry in their research.
Finding inspiration is challenging. As an engineer, we look at some common problem which we are facing, and we look at nature, how it has overcome those problems.
Have you ever seen a flag flapping in the wind? Air flowing around the fabric of the flag causes it to move, but change the airspeed and the flag's fluttering changes. The science of studying the flow of gases like air or liquid is called fluid dynamics. Durgesh and his PhD student Rodrigo Padilla are learning how air flows around a moving object similar to a flag.
So the end goal is to learn the physics, learn more about why this particular phenomena is happening. In order to know that, we need to know the velocity around it. And that's why we use this system, which is called PIV, particle image velocimetry, and allows us to look at the velocity around the flag. Once we have this information, then we can connect this with the theory and figure out why it changes from one oscillation mode to another oscillation mode, or one flutter mode to another flutter.
So why would changing oscillations matter? Well, look at this film of the Tacoma Narrows Bridge built in 1940. The design did not take into account the impact of high winds. And as the winds increased, the bridge began to oscillate. See what happens.
No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes!
So how does all this tie back to biomimicry and Dr. Durgesh's experiment?
If If you think about helicopter blades, they are very thin, they are moving fast, and they will start oscillating. So we want to minimize it. So one way is like make it very strong, but the penalty is it becomes heavy. So we want to reduce that as much as possible. So that's if we know the theory, if we know the physics around it, we can come up with a better solution. And that's where biomimicry also comes up. We look at nature, how it has overcome these things, and we can implement that in the solution.
And so that's biomimicry. If you want to learn more, head to the Science Trek website. You'll find facts, links, games, material for educators and parents, and much more. You'll find it all at sciencetrek.org.